Welcome to this edition of the NASP Product Spotlight with Apex Cool Labs, the innovators behind the Narwhal palm cooling device. Born from a passion project and grounded in cutting-edge science, the Narwhals have quickly moved from basement prototypes to adoption by professional athletes, firefighters, and industrial workers alike. In this interview, co-founder and CEO Evie Lyons and CTO and inventor Ariel share the story of how Apex Cool Labs began, the science behind palm cooling, and how their technology is transforming the way we think about heat stress, safety, and performance.
I'm Evie Lyons, and I'm the co-founder and CEO of Apex Cool Labs.
I'm Ariel. I'm the CTO and inventor of the Narwhals here at Apex Cool Labs, our palm cooling device. And my background is I'm a physicist.
The way that Apex Cool Labs got started is actually pretty out there when you think about where we are today. So a couple of years ago, I'd say late 2021, both Ariel and I did not know each other at the time, and we both heard a podcast where Dr. Craig Heller from Stanford University was speaking about his 20 years of research on palm cooling. And this technique, palm cooling, has been used and studied in a number of different use cases early on in heat stress mitigation, which we'll get back to, but then more recently in strength training and sort of athletic performance. And in particular, we were listening to a podcast where they talked a lot about how if you cool your palms between sets of resistance training, you can add more volume. And we were both very interested in how to do this because we both have a passion for pull-ups and wanted to do more pull-ups and basically independently tried to hack a device for doing this. Because at the time, there was nothing on the market, not a single device was available to do palm cooling. And we'll get into why you need a specific device and you can't just hold ice and things like that. But there was nothing available. So I actually tried to hack it with a bucket of cool water. And I published about my hack and sort of on the internet and asked, hey, is there anybody out there who knows what they're doing? Am I doing this right? And I got very lucky that Ariel found my tweet and replied to it. And it turns out that he had been inventing something far more sophisticated than a bucket of water.
Yeah, so as Evie said, I independently heard the same podcast. And my background being physics, I went out and read the papers on this technique because on the podcast, they discussed the results, but not really the secret sauce of how you do this well. So I wanted to understand what are the parameters you need to hit. A bucket of water actually doesn't really work very well. So the first thing I did was went to my local plumbing supply store and put together some plumbing parts to make a recirculating loop of water at the right temperature with good thermal conductivity that you could hold on to. And that's how I met Evie. After I made that prototype, I said, hey, this works incredibly well. Is there anyone else trying to do this? Found her tweet, invited her and her husband over to try it out. So she did push-ups and pull-ups in my basement. Her husband and I made one of those original prototypes. And then I got real curious as to if I could make something that was portable. So this was all just a passion project. This was not a business idea at the time. And came up with the first concept of what the modern Narwhals look like. Basically this insulating cylinder with heat pipes as the handle. And that worked incredibly well as a portable device. So I brought those to Evie since she'd been such a good field tester of that plumbing parts device. And she was like, oh, you got to sell this. So we thought we'd originally be selling to fitness enthusiasts like ourselves. Very quickly, we were selling to NHL teams. And that really told us there was not only a really interesting market there for athletics, but hockey players are an amazingly similar use case to a lot of occupational heat stress. They're large people working hard in heavy insulating gear, and they have big thermoregulation problems. So it's surprisingly compatible. And that started to lead us down the road of people like firefighters, occupational heat stress, and these other use cases where people need to thermoregulate. And that's what brought us to our more modern device, but we can get into that later. They're similar ideas, right? So what you're trying to do in both cases really is cool your blood. Let's start with the armpits and groin. The reason you would put cool packs there, ice packs there really, is you've got large arterial connections in your armpits and groin, and then you can cool off the blood there. And the key to those arterial connections is they do not vasoconstrict or squeeze down under ice temperatures. But if you think about that tube, it's quite small. The analogy would be if you wanted to cool down your car, you could put cool water on your radiator hoses, or you could put cool water on your radiator. So your palms actually get about 10 times more blood flow than other skin areas when you're hot. But they're a very large surface area. So you can actually dump far more heat through your palms than through these arterial connections. The key is these connections in your palms vasoconstrict, squeeze down under ice temperatures. So you need to hold something cool, not cold, something in sort of the 50 to 60 degree region. That will allow you to get good heat transfer, and actually more heat transfer than you can get through your armpits or groin. But it needs to be cool, not cold. That way you're not vasoconstricting, you're still cooling your blood. If you hold ice, it's just too cold. You will shut down the effect. So in the palms of our hands and actually the soles of our feet and our face, any of the hairless portions of our skin, we have direct connections between arteries and veins. So normally we've got arteries going to a capillary network going back to veins. In the palms of your hands, soles of your feet, you have what are called arteriovenous anastomoses. These direct connections between arteries and veins. So you get really high blood flow. But if you hold ice, those vasoconstrict. So you shut off the effect completely. Therefore, you need to be holding something cool, not cold. Ice basically doesn't work. It might feel okay for a little bit, but it doesn't actually transfer that much heat out of your body through your blood.
Yeah, I mean, so this is, when it comes to cooling in general, I think there's a lot of misconceptions. There's also just a lot of confusion. We're all taught different things as we grow up, like the armpits and groin, which, if you have nothing else available to you, is certainly a good thing to do to cool off, but not the best. And one of the things that we're often taught is let's, put a cold towel around your neck. And the science on that is pretty clear. It actually does nothing to remove heat from your body. You do not lower your core temperature. There are not any sort of improvements in other physiological measurements of fatigue. It does not, they've done a lot of studies on cool towels with athletes, and it does not improve their time to exhaustion. So it feels good if you're in the heat to put something around your neck. However, it doesn't remove heat, and it can actually, in some cases, be counterproductive. And the reason for that is that when you cool your neck, it actually sends a signal to your brain, which is, your hypothalamus regulates your thermoregulation. And when you put the cold towel around your neck, it sends a signal to your brain that, hey, I'm cooling down. So you don't have hey, body, you don't have to do anything anymore to help cool me down. And so you can actually slow your sweat rate, which, sweating is actually one of our greatest mechanisms as humans for cooling off, especially if you are not in a very humid environment. So anyway, if you tell your body, hey, I'm cooling off when you're not, that can be counterproductive and actually cause your core temperature to rise. So I think there are a lot of different tools out there to cool down. But by far, sort of the most impactful are going to be anything that can help your sweat evaporate. That is evaporative cooling. And obviously palm cooling, which is really conductive cooling, but passing that heat directly out of your blood into into a device that can absorb it.
It's also worth, I think, noting for your audience that one of the really interesting things about temperature perception is all of your conscious access to temperature information is peripheral. It's on your skin surface. You don't really have access consciously to your internal core temperature. You feel hot from your skin feeling hot, but you can actually not feel so hot, but have an internal core temperature that is rising. And the way you get access to that is, oh, I feel nauseous. I have brain fog. I'm starting to faint. I get a cramp. Your body does have those signals, but they're not in that temperature perception kind of sense. So that's what can be a little tricky, is that things can feel nice on your skin, but not actually be doing much to remove the heat. There are even great studies on firefighters where they're standing after working and their core temperature, even though they're standing in the shade, maybe with a breeze, they might be feeling okay. Their core temperature is continuing to rise because they're not catching up to their thermoregulation needs. So temperature perception is an interesting piece where there's a big difference between what you have conscious access to and what might actually be going on internally.
So the narwhals are used basically anywhere where heat is either going to inhibit your performance or inhibit your safety, put you at a safety risk. So beyond occupational heat stress mitigation, we see adoption in elite athletics, where it has been, it's very widely known that if you can lower your core body temperature either before or during a competition, you can perform better. You will have greater stamina, you will have greater power, you'll have greater muscle energy production at the cellular level is really what's happening. So the narwhals are used in every single major league sport in the United States and beyond. They are used primarily in in-game recovery. They're also used by Olympians in a lot of different sports, from mountain biking to basketball and even wheelchair basketball. And that's actually a really interesting use case. It really shows the power of the technique of palm cooling to impact sort of your general core body temperature. And so just a note on that one, adapted athletes, so athletes with especially spinal cord injuries, often cannot sweat below the level of their injury. So they may not be able to sweat in their lower body at all. And that is obviously causes huge problems when it comes to overheating, because again, sweat is one of the best mechanism we have to cool down. And so we work with the US women's wheelchair basketball team, as well as actually the University of Alabama has one of the greatest purpose-built gym training facilities for adapted athletes. And so their sports medicine team has brought in the narwhals to use in training and competition to help their athletes thermoregulate.
Yeah, I mean, all of those are important, right? So the idea is there is not a single strategy that's going to make people completely safe when it comes to heat. Heat is a big, big issue. So you need proper hydration, and that needs to include not just hydration, but proper electrolytes. You need rest. You want shade. You need the ability to cool down, some way to monitor people for heat stress. So the narwhals add to that. A great example would be if you're a worker in hot conditions where you have heavy insulating gear potentially. So that's something like a firefighter, or maybe you're a factory floor worker that the factory itself is hot and you need some sort of protective gear on. As we talked about, your sweat is an amazing mechanism, but in most places during a rest period, you're not going to be able to strip down in front of a fan and be able to have your evaporative cooling work as well as you can. Also, many of the places we work with are incredibly hot, humid conditions. So depending on how well your sweat can work, your sweat only works if it evaporates. So if you've got something covering you, or it's humid enough where your sweat's just dripping off you, sweat dripping off you basically does nothing except dehydrate you for the most part. So this basically adds to those other mechanisms where you now can remove some heat from your body. You can lower your perspiration rate, which is going to allow you to hydrate better and lose less electrolytes. So there's basically a cascade of benefits if you're using these during a cooling break. You're sweating less, you are removing some heat, you're getting less dehydrated, and you can hydrate while using these. You can just hold one for a moment, sip on some water, some electrolytes. So there's that cascade of benefits which comes from being able to add on to things like evaporative cooling, a cooling break, rest periods, shade, breeze, fans. The basic science here, as we said, is heat flows from hot to cold. So the name of the game in palm cooling is go as cold as you can without causing vasoconstriction. That is this cool, not cold condition. Most palm cooling devices and most people, it's going to work best to be between about 50 and 60 degrees surface temperature. So the way narwhals do that is made to be a pretty simple but elegant system. So we start off with a vacuum insulated stainless steel container. And then part of the secret sauce are these specialized cool, not cold packs. So what's key about these is they are filled with a material that has a melting point above that of ice. So we'll go back to a little bit of high school physics, where if you took ice from a normal American freezer is about 0 degrees Fahrenheit. That ice would warm up till it reached its melting point, 32 degrees, and then stay at 32 degrees till it melts. So when someone's going through a phase transition, when it's going from solid to liquid, it maintains a constant temperature and it stores an incredible amount of energy. We can get into the numbers there, but we'll just say ice stores a lot of energy compared to just plain water when you're trying to heat it up. So these you put in here with a little bit of water as a working fluid, put on the top, and basically they're ready to go if you give them a cocktail shake for about 1 minute. And that specialized cool pack keeps the internals at that cool, not cold condition. And then the heat from your hand is transferred through the handles, which are made out of heat pipes. So heat pipes are a really interesting technology. I'm happy to explain how they work, but the key is there are no moving parts, heat pump. And the reason for that it's important is you also want to avoid what we refer to as a thermal barrier. So if you were to hold just a cold or a cool aluminum can, you will locally warm up that aluminum can where your hand is touching. And now you won't get as much of a thermal gradient. You won't have as much difference between hot and cold. What heat pipes do is keep that surface temperature continuous on your hands. So you're continuing to move the heat effectively away from your body.
When somebody is holding the narwhals, there's a couple of different things that you can track, as well as that they will feel. The easiest to measure and perhaps quickest, I think, to see is heart rate. So heart rate and core body temperature are highly correlated. The hotter we are, the faster our heart is beating, and that is in part because we're trying to send blood to the skin surface and radiate that heat out. So it's very easy to measure heart rate on somebody, non-invasive, and see very quickly when you're holding onto the narwhals that heart rate recovery after a strenuous bout of exercise. You can also measure core body temperature. You can measure things like blood lactate levels as well, which is a marker of sort of physiological stress and how hard you're working. And there's other things that some of our athletes have measured around blood oxygenation levels as well, and seeing a very quick recovery in blood oxygenation. So basically, markers that are associated with fatigue are what you'll see improve when you're holding on to the narwhals. And in order to sort of get that benefit, you want to hold on to the narwhals for 2 to 10 plus minutes. And I say that it really depends on how frequently are you breaking, how heat stressed are you. And that's where we see quite a range, where you'll see athletes using these during media timeouts for a very short period, but frequently. You'll see firefighters using them in their incident rehab protocols when they have, 10 to 20 minutes to recover. So, but they are not obviously breaking as frequently. So that's sort of why there's this range.
We should also mention there's a lot of nuance to measuring core body temperature, and core body temperature, even a half degree or 1 degree change in core body temperature is a large change. You're generally not going to notice or see that in a measurement holding the narwhals in 1 to 2 minutes. That tends to be more in that 5 to 10 minute range where you're going to move the needle on measurements of core body temperature. But that's a whole other subject of the measurement of core body temperature.
Yeah, winning the National Safety Council's Heat Stress Mitigation Challenge was truly just a massive door opening for us. It was actually our first true event. It was sort of our first experience in an occupational safety conference. And it was very cool to be selected as one of the finalists. And when we were there speaking to various practitioners in safety from across industries, what was interesting and the reason I think we won is because they are looking for simple but effective, practical solutions, things that are easy for employees to use, don't take a lot of training, don't have a lot of components to break or learn and things like that, but also that are effective. And I think that there's also a little bit of a perhaps wearable burnout where there's a lot of technologies out there that can monitor your core temperature, but they're just monitoring. And so these companies might have some of that, but they don't have, like, what do you do? Okay, you're monitoring, somebody's hot. The best you can really offer them today is hydration and shade. And going back to that other question, really when it comes to regulating core body temperature and mitigating heat stress, it's really more of a trifecta of hydration, shade, and cooling. And if you can bring those three things together in your heat stress mitigation kit, they can be very powerful. So this was really great recognition and just visibility that led us also to discover use cases that we were not yet aware of, and just industries where heat is a significant issue that we hadn't necessarily come across. So the National Safety Council held this heat stress mitigation challenge, and it's part of their Work to Zero program, which covers a number of different occupational threats, whether that is heat. They also have other programs for repetitive injuries and things like that, repetitive task injuries and things like that. But this was the first time they'd really focused on heat stress. And so in addition to the challenge, they also offered grants to the finalists, basically creating an opportunity for companies to pilot our solutions. And so one of the companies that took advantage of that is called WSP, a global engineering consultancy firm. They have a really interesting, heat issue, and that they have thousands of employees going out to the field, but they are often in places where there is no infrastructure. There's no field office. They're going out to a field location and performing a job for 1 to 2 days, maybe 1 or 2 weeks max, but there's nothing there for them to provide shelter or anything cooling other than their vehicles. And they're not always at their vehicles. So we worked very closely with them to figure out a kit that could be taken into the field that could keep the narwhals cool all day, make sure they have access to them even when they're in these remote locations.
So we've tried to make every piece of the narwhals pretty robust. You'll notice that the vacuum insulated stainless steel container is covered by this ruggedized covering, and every single plastic injection molded piece of the narwhals is made in the USA with really high quality materials. So this is a TPV that's UV stabilized. The handles are made out of glass-filled polypropylene that's UV stabilized, so that can handle tough outdoor conditions. That's actually what a lot of gun stocks are sometimes made out of. And with the insulating covers on, these are pretty drop proof. The one thing that's a little tricky is if they're completely filled and you drop them on the top, there is some damage potential. So they are not yet 1,000% bulletproof, but we have had no breaks in the field as of yet. So they're out there being used by fire departments, being used in tough conditions, and so far we've done quite well. And the Cool Not Cold packs are also made to be quite drop proof. We've dropped these from 2 stories. We don't recommend that, but they have survived a 2-story drop. So every piece is meant to be pretty rugged, but if it can be broken, someone will break it, right? So.
One of the things that people like about the Narwhals is that there are no moving parts, there are no electrical components. So it is very easy to use. Number one, it's just easy to use. And number two, it can be used in places where it's important to not have electrical components, oil and gas and things like that. So there's a lot of benefits to always having a version of the Narwhal that is not electrical, is not connected to anything. And that I think we will always have. There are, we have certainly thought about different technologies that could be interesting to integrate with, that could monitor your heart rate while you're cooling down and give you feedback on where you're at, and personalize the length of cooling recommended to you, for example. But again, right now we're just really focused on getting the current product out and learning what are the use cases and what are sort of the potential product developments that we would consider based on those use cases. And you had brought up earlier the hub situation. I think that's something we've definitely heard demand for, something, a version of the Narwhal that is stationary, that was something that people could go up to as a station in a factory, or that would just make it easy to know where to go, but also make it less likely for the narwhals to get lost. But Ariel, I know you always have a lot of ideas.
Well, I mean, I think part of your question, it's really about finding those right partners that think about this as a system. So if there's someone who already has a really good heat stress monitor, that maybe they sell these as a kit or things together where they're bundled, where it's here is the way to monitor, here's the way to have an intervention. So it's we in our business model are not interested in making a wearable, if you will. So as Evie said, we do have some thoughts about would it make sense to integrate certain sensors into the device itself. But in terms of heat stress mitigation, there may be room for a partnership with a company which might say, oh, you're up to a certain heat stress index, go hold your narwhals for 5 minutes, right? So something that's more in that vein of integration where there's a protocol, procedure, or prescription for introducing the narwhals into someone's daily practice of safety, but not so much for us to make a wearable. There's several. I'll talk about a few. You should talk about the use case WSP told us about, the sort of anecdotal story. But we work with, obviously, we said fire departments. We have begun to work with some people in the military. There's a lot of interest in when you're in these tough environments or in training for the military where you've got heavy insulating gear in hot environments, heat stress is a real issue. We work with several factories that the nature of their work. So we work with one plastic extrusion factory that's in a hot, humid environment. They run 24 hours a day, 365 days a year, and the factory floor is between 120 and 130 degrees. So it's just a hot, tough environment. And we've gotten good feedback so far, people enjoying them. And we even have some anecdotal cases that Evie can tell you about where we have seen true heat stress recovery.
Yeah, so this would be in the field, where the largest sort of field use case for the narwhals today is really being run through WSP engineering consultancy, again, across multiple business units. So there's construction, there's mining, oil and gas, and other sort of environmental science applications where their engineers are out in the field. And in one particular case, they're piloting and they have a certain number of sets that they are sending out to different sites. And in one case, they were at a site where they were also working with some subcontractors who did not have the narwhals. And one of their employees was working in the heat for several hours, started to not feel well, and was brought into the field office. And they immediately gave this individual the narwhals to hold on to. And within about 5 minutes, this person just had a sort of turnaround where they went from very unwell to feeling much better, cooler, and feeling no longer the symptoms of heat illness. And the feedback there from the field was just really, incredible when they saw somebody who was clearly unwell turn around so quickly. I will also just call out that, the narwhals are a great intervention for heat, those early signs of heat illness. They are not an intervention for heat stroke. So I just think it's important to call that out. But if you are starting to exhibit symptoms of heat exhaustion, holding onto the narwhals, especially for that 5 to 10 minute longer period, is a very effective way to offload heat.
Where we really cut our teeth, if you will, on seeing the effects of heat stress mitigation is last year we worked extensively with something known as the Firefighter Challenge. So this is this obstacle race course where elite firefighters run the course, basically doing firefighter type tasks in a timed course. And we were working in their recovery tent, often in very hot, humid conditions, and saw firsthand being able to bring people back from very heat stress conditions. A couple people had gone a little too far, right? And they got into that place where it's like, oh, you need to get them an ice bath, you need to get IV fluids into them, things like that. But for the vast majority of cases, where if you can catch someone in that heat stress, not moving towards heat stroke condition, you can really bring some people back. And you can literally see it. You can see someone go from flushed and just really overheated and a little brain foggy to getting back to a normal balanced state. So that's where we've really field tested, if you will, the heat stress mitigation abilities of this device.
Thank you for joining us for this look into the science and innovation driving Apex Cool Labs. From elite sports to critical industries, the narwhals are proving that simple, science-backed solutions can make a powerful impact on performance and workplace safety. To learn more about Apex Cool Labs and the Narwhal, visit their website and explore how palm cooling can help you beat the heat. There's a link in the description. Until next time, stay cool and stay safe.